Hi dear students, we have a new session of Brainiacs doubt clearance. The chapter handled here is solutions. Okay, I will just read the question. The boiling point of pure acetone is 56.38 degrees Celsius. When 0.707 gram of a compound is dissolved in 10 gram of acetone, there is elevation to 56.88 degrees Celsius in boiling point. What is the molecular weight of the compound? Okay, now we are going to say about a solution. So here you could know that the solvent used here is, okay, what is the solvent used here? So I can say the solvent here used is pure acetone, correct? Pure acetone. Okay, now what is happening to that? We are adding some compound, right? Adding solute, but they are not mentioning which solute is added. So on adding solute, what is happening to this one? This is becoming a solution, correct? And what they are talking about, they are telling pure acetone has a boiling point of 56.38 degrees Celsius, and when say 0.707 gram of that particular solute is dissolved, okay, in how much gram of acetone? 10 gram of acetone, the temperature or the boiling point increased to a new value 56.88 degrees Celsius. So if this is the case, what is the molecular weight of the compound? Okay, so starting from our fundamentals, we know that the elevation in boiling point delta TB is equal to, we know that Kb into molality. Okay, so here we should know that there is no Van Hoff's factor will come into picture I, because we don't know whether the solute is ionic and that will dissociate or associate. So we will say delta TB is equal to Kb into molality. Now what is delta TB? That is the difference of the temperature, difference in the boiling point. So we know that the difference in the boiling point is nothing but 56.88 degrees Celsius minus 56.38. Now, many students will ask, sir, do we need to convert this into Kelvin? When you are taking the difference, there is no difference if you do the difference in degree Celsius or in Kelvin. You will get the same answer. So it is better that you take the difference directly. Okay. And what is the Kb value given? So here, Kb of the acetone that they should give in the question. So please mention here Kb for acetone. Kb for acetone is given as Kb for acetone is given as 1.72 Kelvin kilogram per mole. Okay, mole raised to minus 1. So we'll take that value. Okay, 1.72. Okay, multiplied by molality. So molality we know it is nothing but weight in gram of the solute. So we know that W number of moles of the solute. So we will write it as W weight in gram of the solute by molecular mass of the solute, correct? Divided by mass of the solvent in kilogram, correct? So we can write mass of the solvent in kilogram in kg. So we can start substituting. So delta TB, what is the value you will get? So delta TB, if you do, you will get the value 0.50, correct? Is equal to 1.72 into weight in gram of the solute. So we know what will be the weight in gram of the solute. So we can say they are given in the question 0.707, correct? So we'll write there 0.707, correct? And molecular weight of the solute is what you need to find it out. So I will put here mm solute, molecular mass of the solute. This I am taking into the numerator. So since they have given the mass of the solvent in grams, we can multiply by 1000. So into 1000 divided by mass of the solvent in gram. So I can put here 10. Why we are multiplying by 1000? It is nothing but in gram you should divide by 1000, so that 1000 will come to the numerator. Okay. So from this we can find the molecular mass of the solute. So molecular mass of the solute is equal to, I can say, 1.72 into 1000 into 0.707, correct, divided by 0.50 into 10. So this, if you calculate, you will get a value 243 approximately. Okay. So we have calculated the molecular weight of the solute. So this is the basic way we need to handle the question. So if you have more clarity needed in this formula, I can write it in that way also, so that you will get a clear picture. I will take another color. So I can say how I have written molality. Molality can be written as molality. The basic fundamental definition is number of moles of solute, correct, by mass of the solvent in kilogram, correct. So this can be written as what I have written, like weight in gram divided by molecular mass of the solute, correct, by mass of the solvent, very very important, mass of the solvent in kilogram. Okay, the other way, when it is given in gram, this can be written as how, please remember this formula also. This can be written as weight in gram of the solute by molecular mass of the solute into 1000 divided by mass of the solvent in gram. So if you have liked our explanation, please subscribe our channel. And if you need more theory sessions and everything, you can contact Brainiacs Classes. Thank you.